All right, guys, we're on the back side of day 8 notes, and number 4 says an angle theta has a terminal ray that falls in the second quadrant. If it is known that sine theta equals 3/5, using the Pythagorean identity, determine the value of cosine theta and tangent theta. So we could use the same method we've been using with the triangle method and put it in the correct quadrant, but this one specifically says to use the identity. So we're going to write down the identity first, which is cosine theta squared plus sine theta squared equals 1. Okay. We're going to go ahead and take out sine theta and replace it with 3/5. And therefore we get cosine theta squared plus 3/5 squared, which is 9 over 25 equal to 1. We'll go ahead and subtract 9/25, and we'll be left with cosine theta squared equals 1 minus 9/25 is 16/25. And then we'll go ahead and square root both sides, and we end up with cosine theta equals, and technically it's plus or minus 4/5. All right. Remember that they said that this is a quadrant 2 angle. So all students. So in the second quadrant, sine theta is positive, and therefore cosine theta is negative. So we'll reject the positive, and we'll go ahead and say that our answer is cosine theta equals negative 4/5. And there's our answer. Okay. They also want us to find tangent theta. So we'll go ahead and say tangent theta equals, and in order to do tangent theta, since tangent doesn't make it into the Pythagorean identity, we have to remember that tangent theta is equal to sine theta divided by cosine theta. Sine theta is the one that they gave us, which is 3/5, divided by cosine theta, which is negative 4/5. And hopefully you guys remember that the 5s on the bottom, if we do a keep change flip, would cancel. And we end up with tangent theta equal to a negative 3/4. And there's tangent theta. Okay. All right, guys, number 5. It says an angle theta has a terminal ray that falls in the fourth quadrant, and cosine theta equals 1/3. Okay. Using the Pythagorean identity, determine the value of sine theta in simplest radical form. So again, because they said the Pythagorean identity, we're going to go ahead and start off with, I almost wrote the Pythagorean theorem, which is almost the same thing. Okay. It's just instead of a squared, it's cosine theta squared. Instead of b squared, it's sine theta squared equals our radius squared, which is 1. All right. They asked us to find sine theta, and they gave us cosine theta. So we're going to go ahead and replace cosine theta with 1/3. And then we're going to go ahead and square 1/3. So squaring 1 is 1, squaring 3 is 9. We're going to go ahead and take away 1/9. And that way we end up with sine theta squared equals 8/9. Okay, 1 minus 1/9 is 8/9. We'll go ahead and square root both sides, and we end up with sine theta equal to positive or negative square root of 8/9. So that would be the square root of 8 over the square root of 9. Now the square root of 9 is 3. Okay. We got 2 things left to do. We have to go ahead and simplify that radical. Square root of 8 will break up into the square root of 4 and the square root of 2. And then the square root of 4 will become 2 square root of 2. So we'll go ahead and replace that. And at the same time, they said that this is a fourth quadrant. So all students take calculus. Cosine theta is the only one that's positive in quadrant 4, and therefore sine theta will be negative. So our final answer here will be that sine theta is equal to negative 2 square root of 2 over 3. And there is our exact value of sine theta. Okay. All right, let's take a look at number 6. It says that point M, which is at t, 4/7, is located in the second quadrant on the unit circle. Determine the exact value of t. Now this one doesn't say to use the Pythagorean identity, so we wouldn't have to, except that's what we're practicing today, so we might as well, okay? So we'll write down the Pythagorean theorem, which is cosine theta squared plus sine theta squared equals 1. All right, they gave us a little bit of a hidden information. So this 4/7 is representing the y-coordinate, and our y-coordinate is sine theta. So we'll replace sine theta with 4/7. And we're asked to solve for t, which is the x-coordinate, which is cosine theta. So we'll leave this cosine theta squared plus 4/7 squared. 4 squared is 16, and 7 squared is 49. Okay. We'll go ahead and subtract 16/49. And we'll be left with cosine theta squared equals 1 minus 16/49 is 33/49. And then we'll go ahead and square root both sides so that we get cosine theta equals square root of 33 is not perfect, so we'll leave it, and the square root of 49 is 7. Okay, technically this is plus and minus because we square rooted both sides. They told us this is a second quadrant angle, and in the second quadrant, sine theta is the only one that's positive, and therefore cosine theta will be negative. Okay, and so our final answer for cosine theta is negative square root of 33/7. And remember that we were asked to find the exact value of t, so we could say t equals negative square root of 33/7 if we want to make our answer a little bit more specific. Okay, guys, let's take a look at number 7. It says for an angle theta whose terminal ray lies in the third quadrant, it is known that cosine theta equals negative 0.96. Which of the following is the value of sine theta? So we'll go ahead and use the Pythagorean identity. So cosine theta squared plus sine theta squared equals 1. And they're telling us the value of cosine theta. So we'll get rid of this and replace it with negative 0.96. Okay. So we'll go ahead and square negative 0.96 in our calculator. And we end up with 0.9216 plus sine theta squared equals 1. We'll go ahead and subtract 0.9216. And we end up with sine theta squared equals 0.0784. We'll go ahead and square root both sides. And sine theta comes out to equal positive or negative 0.28. Because they told us this was in the third quadrant, all students take calculus. In the third quadrant, tangent is positive, and therefore sine must be negative. So we'll go with negative 0.28, which is choice 1. All right, number 8, a little bit different, but they said that the expression is equivalent to which of the following? And this one's a tough one for a lot of us because we have to recognize this top right here. That top comes from the Pythagorean identity, so let me just show you. Pythagorean identity is cosine theta squared plus sine theta squared equals 1. If we move cosine theta squared, actually, no, I don't want to move cosine theta. I want to move the other one. So it looks like what we have up on top. We're going to move sine theta squared over to the other side. Okay, so this will be gone. And so we end up with cosine theta squared equals 1 minus sine theta squared. Okay, except they rewrote it without the parentheses around it, and so the squared hops to on the sign. All right, but you guys can see this is what we have on the top of our fraction, and so we're going to cross it all off because we know that it's equal to cosine theta squared. All right, so we don't have our answer yet, so I'm just going to do one more thing. Instead of theta, so it looks a little bit better, they're using A as our angle instead of theta, so that might help us. Also, we have to realize if cosine of A is being squared, that really means cosine A times itself cosine A. That's what squaring something really means. And then on the bottom, I'm going to rewrite this as 2 times cosine A so that you guys can see the multiplication between, which allows us to cancel a cosine A from the top and a cosine A from the bottom. And what we have left is cosine of A on top divided by 2 on the bottom. And I think you guys can see that that's choice 2. Okay. All right, last question, guys, number 9. It says the expression sine squared x plus cosine squared x minus b squared is equivalent to which of the following? All right, so in this one, I think you guys can maybe see that this part is the Pythagorean identity, okay? And that this is really equal to 1. And so when we replace that with 1, our new expression is 1 minus b squared. And I'm not quite sure if you guys recognize this, but this is a D2PS. That if I were to factor it, it would factor into 1 plus b and 1 minus b. And that is choice 2. Okay, that one was a tough one to see. All right, guys, I'll see you on the next day of notes.